Alright guys, in this video we're going to talk about the properties of parallelograms. First of all, we're going to talk about the parallelogram definition. And basically, it's just a quadrilateral with opposite sides that are parallel. So remember that we can mark opposite sides parallel by putting arrows on them. So these opposite sides that I just marked are parallel, and then these other pair of opposite sides I can mark parallel with double arrows. Remember, arrows mean that those sides are parallel. So now let's get into what else do we know about parallelograms. Well, here are two properties of parallelograms that we know. We know that opposite sides are congruent, so that's why they have this side marked congruent to that one, and they have the other opposite side, this side and this side are marked congruent. And we also know that opposite angles are congruent. So if I think about angles in the opposite corners, those will always be the same size angles, just like these will be. See how they are marked with those double arcs. Remember that these right here, here we go, right here. These arrows mean that these are parallel, and that's just indicating that it's a parallelogram. It's the new stuff with the angles and the sides being congruent are the properties we know about parallelograms. So let's do a couple examples using these properties. So in this first example, I'm supposed to find the value of the variables, and here's x. Notice that 2x is this angle, and then they tell me this other angle is 122. Well, we just said in the second property that opposite angles are congruent. So I'm going to make an equation that says 2x is equal to 122. And then I'm just going to solve by dividing both sides by 2. And that's going to give me x equals 61. Now for y that's a side. That's representing this side right here. And then that side across from it is 7. And we know from the first property that opposite sides are congruent. So I know that y is just going to be equal to 7. So we've solved for both of those variables. Let's go to the other one. So in this diagram, x is right here. It's an angle. And its opposite angle is the angle with a variable y in it. So now we have kind of a problem here. We know that x should be equal to y plus 10, but I cannot solve that without knowing more information. Now they told me that this angle right here is 70, but 70 is not congruent to x. That's not opposite of it. So actually what we need to do is look at the third property, and I'm going to come down here a little bit, and then we'll come back to our example. Our third property says that consecutive angles are supplementary. So they're talking about when they say consecutive, remember we learned about this with parallel lines. This angle x and this angle y, they're not congruent, but they are consecutive interior angles or same side interior angles. So remember that makes that C shape. So we said same side interior angles. We know those are supplementary, which means they add up to be 180. So that's why we know that x plus y is going to equal 180 in this diagram. So let's go back to our example we were just doing and use that to our advantage. So in this diagram, we know that x and 70 are consecutive angles, so they are going to add up to be 180. So x plus 70 is going to equal 180. So if I subtract 70 from both sides, I'm going to get x equals 110. So I've solved for x. Now I can just plug that back into here, and then that'll help me solve my equation. So I can plug in 110 for x. And now I'm just going to subtract that 10 to the other side so I can solve for y. So y is going to be equal to 100. All right, moving on. Let's do the next example. In this next example, 9x plus 2 is an angle that's opposite of this angle, 12x minus 34. So I'm going to set those equal to one another, and I'm going to solve. So first thing I'm going to do is subtract the 9x over. So that's going to give me 2 is equal to 3x minus 34. Then I'm going to add the 34 over to the other side. That's going to give me 36 equals 3x. And now I'm going to divide both sides by 3, and that's going to give me 12 for my x. Good, and that's the only variable in that problem, so we've solved that problem. X equals 12. Now in this last problem, we have two things we have to solve for, a and b. So a minus 10, that's this side right here, that's going to be congruent to the side across from it, the opposite side, the 18 side. So all I have to do is say a minus 10 is equal to 18. Then I add the 10 over to the other side, and I get a is equal to 28. Now for b plus 16, that is an angle, and that's going to be congruent to the angle opposite of it, which they gave us. So I know b plus 16 is equal to 103. So now we just subtract 16 from both sides, and we get b is equal to 119. So there's some examples of using those first three properties. There's one more property, and that's that the diagonals bisect each other. So if you look at this diagram, this piece right here is part of a diagonal. A diagonal just joins two vertices together that aren't right next to each other. And then we also have this other diagonal right there. So you see how those diagonals cut each other in half. So if I am given diagonals of a parallelogram, like I am here, 16 is the half part of this diagonal. So I know the 4m and the 16 are going to be the two equal halves. So I'm going to say 16 is equal to 4m because they are bisected. Those are congruent to each other. And then if I solve by dividing by 4, I get m equals 4. And then on the other diagonal, this one right here, I have 2n is equal to 9 minus n. So I'm going to set that up in an equation. So I'm going to add that n over to the other side. That gives me 3n. And then I'm going to divide both sides by 3. And so I get n equals 3. All right, and this one over here, again, we have diagonals. So we're going to use the property about diagonals. So this 3x is going to be congruent to the 12. So let's make an equation with that. And then I'm going to divide both sides by 3 to get x equals 4. On the other diagonal, this one right here, I have 5y is congruent to this one. And sometimes it's hard to tell in a diagram where this is talking about. So if you ever have questions, please ask. But the main thing I want you to know is that this half of the diagonal is congruent to the other half of the diagonal. So now we're ready to solve. So I'm subtracting 4y, and that's going to give me 1y is equal to 4. All right, so we're going to move on. So flip over to your back side of your notes, and we're going to look at this diagram here. We have 4 questions we need to do, so we're going to do step by step. The first one's asking about EDG. So I'm going to trace that EDG. That's this angle right here. Well, again, if I'm talking about angles, I'm going to see what do I know. I'm given this double arc right here at angle G. That's the consecutive angle. And they tell me that that's 7x plus 4. And then they also give me this opposite angle, and they tell me that that's 50 degrees. So I'm going to use the opposite angle because they told me what that angle measure is. So I know EDG is going to be congruent to 50. So this is just going to be 50 degrees. All right, so I'm going to erase that so I don't get too cluttered in my diagram. All right, now I'm going to talk about EH. EH is right here. So again, if I'm tracing out part of a diagonal, I'm going to use the diagonal one. So this is half of a diagonal, and it's going to be congruent to this other half of the diagonal, which they told me in this diagram is 8. So EH is equal to 8. All right, moving on to the variables now. We want to find the value of y. So y is right here, and that is a side. So that means I'm going to be looking for the side across from it, this side over here. That is the opposite side. So I can set up an equation. 6y minus 9 is equal to 21. So I'm going to add the 9 over to the other side. That's going to give me 6y is equal to, let me move that down a little bit. Sorry, 6y is equal to 30. And then if I divide both sides by 6, then I get y is equal to 5. So we solve for y. Alrighty then, last variable in this diagram is the x. Here's where the x is, and it's talking about this angle right here. Well, we don't have the angle across from that, so I can't set that equal to anything. So I'm going to have to use the fact that this is consecutive with this angle 50. Remember, that doesn't mean it's equal, it means they add up to be 180. Consecutive angles are supplementary. So I'm going to make an equation, 7x plus 4 plus 50 is equal to 180. And that's again because they're not opposite, they're right next to each other, they're same side interior angles. So I'm going to combine my like terms. That's going to give me 7x plus 54 equals 180. I'm going to subtract that 54, so that's going to give me 7x is equal to 126. And now I'm going to divide by 7, and that's going to give me x is equal to 18. So we've solved for all those variables. Now let's kind of summarize what we know about parallelograms. These are things that help us know we're dealing with a parallelogram. So there's 5 properties, 5 ways to show that a quadrilateral is a parallelogram. So this is before we know it's a parallelogram. So we can use the definition. So we could say, if we know that both pairs of opposite sides are parallel, okay, so you see that, then we know it's a parallelogram. That's just the definition. But we could also say if both pairs of opposite sides are congruent, so we've got that, then we also know it's a parallelogram. So they don't have to have it marked parallel. They could have just opposite sides are congruent, and we know it's a parallelogram. We could also say both pairs of opposite angles are congruent. So notice that I don't have to talk about sides at all. If I know that both pairs of opposite sides are congruent, then I know it's a parallelogram. And then we also have, this is a weird one. Notice up to here, we've had 2 pairs of opposite either sides or angles, either congruent or parallel. Now in this 4th one, I have 1 pair of opposite sides, and it's doing 2 things. It's being congruent and parallel. So I have the congruent symbol and the parallel symbol. So if I know that just the same pair of opposite sides is both congruent and parallel, then it is a parallelogram. I don't have to know anything about that other pair of opposite sides. And then our last one, if we can show the diagonals bisect each other, so this isn't dealing with sides or angles, it's dealing with those diagonals. If we know that both of those are cut in half by each other, then it's also a parallelogram. All right, so we're going to look at these and see if these are parallelograms. So in this first one, I definitely have 1 pair of opposite sides congruent, but I don't have both pairs. This is 75, but I don't know what this one is. So at first glance, it might be like, oh, we don't know if that's a parallelogram. However, remember in last class we said quadrilaterals always add up to be 360 degrees. The interior angles always add up to be 360 degrees. So I could say x plus 75 plus 105 plus 105, that should equal 360 degrees. So if I add all those up, I'm going to get x plus 285, that's equal to 360. So then x is equal to 75. All right, so yes, we are getting that that is also congruent to that opposite angle. So we could say, I'm going to make this zoomed in a little bit. So we could say that yes, this is a parallelogram. And I'm just, so I don't have to write everything all the time, I'm going to say it's by the the third property above. Okay, normally we would write that out, but to save my space on my thing here, I'm going to just say number 3. All right, let's look at this one. We have 98 is congruent to 98, and 73 and 73, so this is yes. We know this is a parallelogram, and that's by the second one. The opposite sides are congruent. All right, this third one, we have a diagonals now. I have this half is congruent to that half, and this one and this one. So both diagonals are bisected. So we would say yes, and that's by the 5th property that we were talking about. In this 4th one, I have, these are all right angles. So it may not, we don't have anything that says all right angles, but we do have something with angles, and that says if opposite angles are congruent, then it's a parallelogram, and notice they are. And notice that actually these are all congruent, but I was showing you that even if they're all congruent, then opposite angles are congruent. So we're going to say yes, this is by number 3. Opposite angles are congruent. And this last one, we have that both of these sides are parallel by those arrows, and those same sides are congruent. They both have 10s on them. So this is that weird one, that number 4, that says if you just have one pair that's both congruent and parallel. So that's going to be a yes by number 4. All right, one more set of problems, and then we'll continue working on this next class. So I don't really like the way these are worded, but we're just basically trying to solve this for x so that we know it's a parallelogram. So in this one, we're talking about diagonals, so these should be congruent. So I'm going to set 3x minus 11 equal to x plus 5. I'm going to subtract the x to get 2x. I'm going to add the 11 to get 16, and then divide by 2, and I get x equals 8. In this second one, I've got this angle and this angle. So those are not opposite, they're same side or consecutive angles. So if they're same side, then they should be supplementary. Same side is supplementary. They have to add up to equal 180. So I'm going to combine like terms, and then I'm going to add that 6 over to the other side, and then divide by 6. And then our final example, we have this angle, and these are opposite angles, so we should set the angles equal to one another. So I'm going to subtract the x over to the other side, add the 13 over to the other side, and then I'm going to divide by 2, and I get x equals 16.